Next. Heritage mapping as a traditional tool. We can see the images, step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8. These all were old traditional methods which is time taking and tedious and does not have the foolproof accuracy. Now we'll be seeing the technology as a tool for heritage mapping. We'll see the first video. This will give you a glimpse what the technology has done for the Nagardhan Fort tram take. If you see in this video, you will be seeing the point cloud datas, the data collected in the form of points. All the detailings of the Nagardhan fort which was documented is captured with foolproof accuracy of plus minus 3 mm. All the minute details, all the carvings, all the openings, all the niches have been captured. The exact tenon has been captured. Today, as it's like an as-built model, the condition which these forts are. You can see the captured point cloud data. Data is captured in the form of point cloud. You can measure the data. The entire fort has been scanned. All the carvings, all the textures, all the impressions, all the carvings have been captured. ये स्क्रीन को नीचे लो. ले ले. Next. After seeing the video, like we just wanted to show the video first. This is the reason, like when we do go for technology, we'll see the output what the video was showing in the form of drawings, in the form of 3D model, in the form of 2D datas and 3D datas, right? Right now, to start with the technology, you have to start with your program strategy and acquisitions. First you have to do the site planning and data acquisition, then you have to do the pre-processing of the data, then the post planning, then you have to decide your deliverables and applications. uh, we'll have in the end question answer session. Next. See, in the site planning and data acquisition, we have terrestrial laser scanner, surveying of the site, then we did identification of the ground control points and marking them for fetching the latitude and longitude of the concerned area, detailed scanning, and you will get the output in the form of point cloud and high resolution images. Major features of the VZ400 laser scanner is the very long range up to 600 meter and very high speed data acquisition, wide field of view, controllable while scanning, high accuracy, high precision ranging based on eco-digitization, and online waveform processing, multiple target capability, superior measurement capability in adverse atmosphere conditions, high precision mounting pads for optional digital camera, integrated inclination sensors, laser plummet and compass, integrated GPS receiver with antenna, various interfaces. You can have LAN, wireless LAN, USB port, internal data storage capability. LIDAR. LIDAR know-how. LIDAR is a light detection and ranging application, is a remote sensing technology that measures distance by illuminating a target with a laser light. LIDAR uses ultraviolet visible or near infrared light to image objects. It can target a wide range of materials including non-metallic objects, rocks, rain, chemical compounds, aerosols, clouds, and even single molecules. LIDAR sensor measures time from when pulse is sent to when received. This translates to distance from sensors to object, GPS knows location of sensor, then you have the coordinates x, y, z are assigned to each pulse. Result is a cloud of points. Each point has its own coordinate and height. And you can see the screen how the path is defined using the GPS. Benefits of LIDAR technology: collect and store data, process data to generate real model for carrying out the preservation and restoration activity. 3D georeference point cloud data used for accurate measurement and reconstruction of project. Improves accuracy of rectified imagery. Faster as compared to conventional total station. Proven cost saving over traditional survey. Detects elevated and suspended objects with respect to height. Interfaces with CAD and GIS software. There are types of LIDAR. LIDAR has a wide range of applications which can be divided into airborne and terrestrial types. Requirements: scanners with varying specification based on the data's purpose, the size of the area to be captured, the range of measurement desired, the cost of equipment, and more. There are two types of LIDAR. One is the airborne LIDAR and one is the terrestrial LIDAR. We will be using combination of both to get the output. See, this is the UAV, this is the aerial LIDAR, and on this what you do, you have to do the flight planning, then you have to do the identification of ground control points, which is called as the GPS points, and marking them for fetching the latitude and longitude of the concerned area. Then data acquisition according to the flight path. After scanning, you'll get the high resolution images. With the help of this high resolution images, the data can be converted into point cloud form. There are UAV mapping. There are two types of UAV. One is the copter, one is the sparrow, and you can see the two images, the orthomosaic which is generated. The data showcased in this presentation is from Manigard limestone project. Benefits of UV mapping: high resolution images which has less than 5 centimeter accuracy and gives capability to capture detailed features, quick data acquisition and processing within 2 weeks, no issues with cloud cover, and can be used for 3D models and NDVI. In the UV mapping process, a survey team establishes a grid of DGPS points from which secondary grid of ground control points are set for reference for the UAV. The UAV team flies several missions and subdividing the target area into multiple capture zones. The geo-reference photo along with the RTK DGPS corrections are imported into the aerial photo processing software. The photos are then merged into large orthomosaic. A combined large point cloud and 3D textured mesh are generated, which has the X, Y, and Z data. The DSM, orthomosaic, point clouds, DAME, and DTM are then generated, removing the unnecessary details. A quality report is generated and verified for the target parameters. And when you do all the scanning, the terrestrial LIDAR scanning, the UAV LIDAR scanning, you will get the data. You can see the three images. You will get the data in this form of point clouds. There are millions of points with having the value of X, Y, and Z. That can give you the dimension, height, length, width, everything. If you see the last image, it has white color circles. That has been used for moving the camera points, terrestrial scanning camera points, which is being moved from by setting a range of 50 meters, 50 meters. You go on an interval scanning it and then you stitch those points. Then you have the 3D model based on the point cloud using the softwares for 3D modeling, which is the BIM, Revit modeling. You can create the entire model with the entire texture, the entire dimension, and you will have all the quantities, everything ready with the help of this software for 3D modeling. Then you have the architectural drawing, which is required for as-built drawing. Will get the data also, plan, elevation section, and the accuracy with the data is plus minus 3 mm. So highly reliable architectural drawings we'll get from this. And the software used from the process data of the point cloud of the scan data. The softwares used most commonly are Pix4D when you have a UAV data, Scene for LIDAR, and Autodesk Recap Pro does both. Then you have the Autodesk Revit, Autodesk 3D Max, and Autodesk Navisworks. In Navisworks you can import the point cloud data and the Revit model. You can do a clash-free coordinated drawings, and you can measure actually in the Navisworks software for a QA/QC purpose, which actually matches to the site. The advantages of the 3D mapping: 3D laser scanning technology is being used in archaeology since it's allowed digitally preserving information through time, giving opportunity to revisit the information over longer time for multiple experts. The continuous development and updating of information allows wider use in activities related to any branch of human and physical science, which leads to automation of activities which can be managed via hypertext or GIS. In case of an emergency, example terror attack, the achieved images, videos, drawings help for defense planning. Compilation of detailed 3D representation of archaeological sites is of great importance for documentation needs and also for restoration purpose. 3D data is used to create maps, facades, and sections that provide information useful for archaeological purposes, such as the investigation of architectural construction techniques or construction phase. From the above we can come to the conclusion like scanning, post-production, pre-production. These are the conclusions which can be generated. Powerful tool for gathering few fulfill 3D coordinates, information about an object or test structure. Richness of detail plus high accuracy plus minus 3 mm. High accuracy potential of CRP in determination of edges, and the high density of points measured on the surface using laser scanner. Only while scanning you have to do the 4x 6x zoom level, you will get the high density data. Combinations best result with reasonable amount of time, effort and equipment. Image based approach more suited when a higher accuracy is required. Laser scanner when high level of detail is required. Requires a lot of user knowledge and experience. Post processing is not fully omitted. You need to give manually process the data and a bit time consuming. It avoids, it's faster. If you see the cultural heritage documentation damage assessment, this can be also done with this. First you have to go in an experimental approach. You have to pre-process the data. Then that data has to be coordinated into transformation. Then you'll get the point cloud unrolling. When you get the point cloud, you have to rasterize multiple scales. Then a database is created, and then you will get a damage detection. For damage detection, you have the terrestrial LIDAR scanning range data. Then you have the RGB data. When you have the RGB data, then you have the depth image. And when you have the depth image, you will go for hierarchical segmentation. And based on the rules of semantic classification, you will detect the damage. Means you have to do the scanning and process the data 2 times. Means if you are seeing a structure, with the weathering effects, if you after 6 months you find the widening of the cracks, widening of the joints. So in this way the historical structure can be seen for damage detection using this technology. Well, we'll go for a live case study which we have completed. We have done 2 case studies. One is the Nagardhan fort at Nagpur with the help of Archaeological Survey of India and MARSEC, and Sinhgad fort at Pune. We'll start with Nagardhan fort. The Nagardhan fort at Nagpur, the need for case study to generate 3D data and 3D modeling of cultural heritage monuments oblique forts that can be used for preservation and restoration, and 3D documentation of as-built drawings. Prior permission from Archaeological Survey of India was taken to successfully complete the work assigned. Nagardhan fort is situated 38 kilometers northeast of Nagpur and about 9 kilometers south of Ramtek. It is an old town founded by a Suryavanshi king. Main attraction of Nagardhan is the Nagardhan fort, supposed to be built by Raja Raghuji Bhosle, a Maratha king of the Bhosle dynasty. The square-shaped palace inside the fort has an outer rampart with bastions and had an inner wall surrounding the buildings. The main gate of the fort on the northwest side is still in good condition. See, while starting with the case study, the first step, site planning and data acquisition. For this we did the survey of the site. Then you can see the second image where you can see the identification of ground control points, which is called the DGPS points, and marking them for fetching the latitude and latitude of the concerned area. Then scanner was placed at those points to capture a swatch area of 50 to 60 meters and moved simultaneously every 10 meters to capture point cloud, photos and panoramic views from 56 locations in all. Detailed scanning of step well, gates, staircase, archery window and watchtower was done. Finally, data was acquired for medieval fortification. If you see the first image and the second image, you can see that with the second image shows the laser scanner, the UAV scanner and the DGPS points, how the data has been come in RGB. And then the point cloud data was used to construct the first image, which is the fort, Nagardhan fort. Pre-processing, here you see this is a point cloud image, and the circle of the white images are the scanner points. You start from one point after 50-60 meter range of area. After every 10 meters you go for go ahead with the laser scanner. The laser scanner footprints can be seen on the point cloud. For pre-processing, see, we have to selection of a parameter, resolution and range, and creating a folder of client name. In the laser scanner, this is the option which you needs to put. Then you have to setting up of a GPRS system to validate north direction. DGBS points will also help. Then for registration of scans, placement of spheres or paper targets with scanner range. You need to have points where you can merge one data to the other. So you can have the checkerboard, black white boards, which where one data merges to the next data and you have a 70% overlap. Scanning starts, scanning complete as per the resolution is set. When scanner starts, first it emits laser in order to create 3D model in cloud which are in millions of points. Scanner emits laser as per resolution. Scanner starts capturing images only after emission of laser is completed. 1.5 minutes is the cycle time for scanner to capture images. This timing is fixed for any resolution as set by the user. When you have scanned, you have to do post processing. When you do the post processing, the scanned data from the scanner, UAV, terrestrial, you take those data in a stepwise. The scanned data is then imported in a scene software which comes along with the scanner. In scene software, radius of sphere or diameter of paper targets is registered, which is called checkerboards. Raw scan data comes in .fls format. These .fls format is then brought in scene software and registration of scan starts. For registration, 3 common spheres are identified in every 2 scans of different locations. Once spheres are identified, these 2 scans are registered by software. It's just a simple stitching step. After exporting it in desired format, the exported register scan data is moved in 3D software for 3D modeling. When you do post-processing, you will get the point cloud data. Point cloud data have to be imported in the 3D softwares. For Revit, you create a Revit model. It becomes a building information modeling. That model you can take in 3D Max, you can render and generate and walkthrough. We have seen first walkthrough at the beginning of the presentation. The deliverables, we delivered a detailed 3D geoinformation Nagardhan fort. This Nagardhan fort, the entire data has the X, Y, Z coordinates. The length, breadth, height is having an accuracy of plus minus 3 mm. This data can be put on globe. And this is the image of developed in a 3D model using Revit BIM modeling. And you get the architectural drawings, plan, elevation sections. Now this is the second fort, Pune. We are seeing all the images. The Sinhgad Fort, Pune, which is located around 40 kilometers from Pune city. This fort is an ancient fort. This has 26 historic structures. All these structures were captured with the help of same style. One is LIDAR scanning, terrestrial. One is the UAV scanning. The LIDAR and the UAV scanning were processed. Point cloud data was generated. With the help of point cloud data, the entire orthomosaic, and you have the Revit BIM modeling. So entire structure was created that has X, Y, Z. The length, width, breadth can be measured at any time and can be cross-checked at the side, and you will get an accuracy of plus minus 3 mm. You can see the images post-production, which is the same as the beauty on the side. Gorichi Paga. One, the Kalyan Darwaja, which is on a very hard terrain. The terrain is also documented. Then you see the Kondaneshwar Mandir. Then you see the Pune Darwaja. Then you see the Tanaji Samadhi. Next is the entire master sheet. You can see the architectural drawing, where the master sheet, on the master sheet you will find the 26 structures, 54 water ponds. The blue sheets give the water ponds. The dark red line orange sheets give the fortified boundary, And just for an architectural delaying plan, we put one Kalyan Darwaja roof plan which has all the terrain, steps, 3 darwajas with all detailings and its south side elevation, how it looks with the steps. And we'll see the walkthrough. This is a Kalyan Darwaja walkthrough, a part of Sinhgad Fort. The entire terrain, the entire fortified walls, all the detailings, niches, carvings, everything captured, converted into point cloud data, converted into mesh form model, converted into a walkthrough animation for tourism purpose. The same model can be used for gaming. The same model can be used for tourism promotion in a kiosk. On the entire fort, the same model with the help of GPS. In the gaming zone, you can know your location where you're in the fort. You can see in the structure the parts are broken, the parts are new, modified. Restoration works can be seen. After the two case studies, we'll see the applications. The applications of this is the generated database can be used for multiple objects such as to present architectural documentation of the structure. In India, if you see, we don't have the documents. The assets of the country's documents needs to be created. So this is a very high-end technology which can be used to generate architectural documentations for the assets of the country. To highlight its architectural significance by highlighting its specific characters and elements, identification of defects and decay of the structure to prepare conservative plans, display architecture of the structure in proper format to ensure authenticity. To create awareness by preparing its GIS map, a video can be prepared for promoting tourism as compared to conventional methods which are tedious, involves more labor and are less accurate, takes more time. This method is more feasible and accurate. So here we are opening the session for discussions, QA, QC. Any questions? What will I suggest, if anyone have questions can write it on the chat and we'll answering one by one, because people are have connected from different places, so all speaking at one time will I'll not be able to answer all questions. So you write it down on the chat box, I'll reply one by one. See, for Rohtash Agrawal, the question was which scanner you have used. So we have used the Faro 3D scanner, and a copter and a sparrow to capture the entire data. Hello. Uh, Questions please. Yeah, we'll be giving you we can give you a training. Shivani, hello. You have written a question called, do we get any kind of training if we wish to learn this 3D scanning? Yeah, we give the
Yes.
training, we give the training and we do POCs for the project. We have done POC for MRSEC, we have done for Archaeological Survey of India, for Maharashtra state, for Chhattisgarh state, and we are in process for Rajasthan. Any more questions? Yes, we have a facility at Nagpur to learn. We have our own. Yes, we have. We have our own UAVs, which is one is the copter, one is the Sparrow. We have our own LIDAR scanning instrument. We have the workstations with all the softwares loaded, high-end workstations to process the data. We have everything. And we successfully completed 3 projects with governments: Maharashtra MRSEC, Chhattisgarh Cultural and Archaeological Department. Yes, you need to contact ADCC for this. You can contact me, myself, Architect Puneet. You can contact Sudhir sir. You can contact ADCC. We'll give you more brief presentations, guidance for scanning of the structure. And we are in process of scanning multiple heritage of the country. Any more questions?
कल कल आना है नहीं तो किसने
Okay, Shivani,
नहीं
let us know the projects, the forts where this conservation needs to done. We'll do the scanning, we'll prepare the data, and rest DPR and rest work you can do. Shivani, you can call me offline. My number would be there. Okay, it seems like questions have been completed, so we'll wind up our presentation. Thank you everyone for joining. Look forward for serving you. Thank you.